away. Okay, so that's how you distinguish in a stress profile pattern whether it's compression or tension. And what we realize down here, right? So this axis over here that I'm going to highlight in yellow, right? This axis over here that I'm going to highlight in yellow is known as the what? Neutral axis. Okay, at the neutral axis is where the normal stress is equal to what? Is equal to 0. Okay. Any questions so far? Are you all okay? Okay, I don't hear any questions. I'm going to
And
do.
also on the right hand side, it says the stress is positive and why it's positive. So why it's negative from one side
No,
and positive?
on the right hand side is only stress X is positive. Okay, so on stress X, right, above stress X line, right, stress X, sorry, on the right hand side of stress X, right, is in tensile, is positive. On the left hand side of stress X, on the left hand side, stress X is compression. Okay, above, on top, Y is positive, below, Y is negative.
So it's according to the neutral axis.
It's according to the axis that we're referring. So let me elaborate, okay? Down here, this axis that I highlight in yellow is for stress X, right? So this is our 0, yes or no? So on the right hand side of the stress X line, okay, it is stress X is positive. On the left hand side, stress X is what? Negative. You agree?
Yes.
Okay. Now, if you look at Y is up or down, yes or no? Right?
Yes.
On the 0 line, above Y is positive. Below the 0, Y is what? Negative. Maybe it is too crowded down here. Right? So let's focus on stress X. So anything on the stress X line on this side is positive. Anything over here, stress X is negative. Okay, this is on stress X. In terms of Y, right? Anything above the 0 line, Y is positive. Anything below, Y is negative. Is that better now?
Yes.
Okay. I think, as I said, it was too crowded. Okay. I realized what is going on when I start drawing. Like, wow, there's a lot of information in there. Okay. Good. Okay. I like that. Okay. If anything that you don't see, I want to explain this because this is foundation. Okay. If you don't grasp the foundation well, yeah, it's very abstract. Okay. Anyone? Any other questions, please? Anyone? No. Okay. So I'm going to I'm going to do one example. Okay, I think wait, is it? Yeah, I'm going to do one example, and this example has a lot of components in there, has a lot of information. Okay, this, as I said again, this example has a lot of information for you guys. Okay, so can I see? Can I do page now? Oh God, hold on. Okay, I'm gonna. So I have posted this example on Avenue to Learn. So if you can go into Avenue, you can also download this example. Okay, so this is my example number 1. Okay. So this is the example we're going to do. Okay, it's not pacing. Oh, it is. Okay, so as I said, this is on Avenue. You can get this from Avenue to Learn. Okay. Okay, let's deal with this example now. Okay. So 60 Newton meter copper is applied to the steel bar shown. Okay, so this is how the steel bar, assuming that the couple is applied in the z-axis, determine the maximum stress. Okay, we are just going to focus on the we are just going to, I'll tell you what we are focused on. We are just going to focus on the maximum stress for now. Okay, so part A, it states that the moment is applied in the z-axis, as you can see. Okay. For part B, right, they're going to switch the moment and it's going to be applied in the y-axis. So part A is exactly what you see in the figure. Okay, so this is part A. Okay, part A. And then part B, they say that this arrow has been switched, right? And then we use right hand rule. We grab the arrow will be in this direction. Okay, so this is for part B. Okay, and whether is it moment in the Z. Okay, so the first one is moment in the z-axis. Part B, moment is about the y. So I'm going to do both. Okay, we're going to do both, and I'm going to do it side by side, and I want you to see the difference. Okay, the most important thing is I want you to see the difference. Okay, so let me write down what is our learning objective down here. Okay, before I go on, and I'm going to go slow. Okay, I'm going to go slow. So the learning objective learning objective is when is the geometry, the width, and depth. Okay, so you're going to see this. So when is it a width and when is it a depth? And I'll tell you this, has nothing to do with English. Okay, I'll tell you this. I thought it was English. English means what? Over here, this is always the width, right? And this is always the depth. And that's wrong. Nothing to do with English. When I was doing my undergrad, the prof did not say anything. He said, okay, this is the width and this is the depth. And because I did my degree in the UK, I thought, okay, width is always this. Okay, depth is always this. No, nothing to do with it. So when is to select the width and when to select the depth. And then we are going to find out which second moment of area to use, right? And most of the time, a lot of times, okay, even myself when I was undergrad, it's very confusing. Okay, when I was undergrad, but I've devised a way that is no more confusing. Okay, it's no more confusing. It's always foolproof now. So I've devised a way that you can visualize this. Okay, not worry. Okay, well, where's the width and where's the depth? Okay, we cannot always second guess ourselves. We have to be very what? We have to be very sure when is a width and when is a depth. Not like okay, it's English. Okay, width. This is always the width because it is a smaller dimension. It's always the width. The deeper one is always the depth. That is not always true. Okay, right. So I'm going to do a. So this is our learning outcome. Okay, I want and also very important. Okay, I'm going to show you. These are not in sequence. Okay, so I'm going to show you regarding deformation pattern. Okay, this is critical. Okay, I want you to visualize deformation pattern. Okay, right. So the first thing we do, we're going to do A first, and then we're going to do our transformation. So from here, we know that our based on the diagram over here, this is X. Over here, this is Y. Over here, this is Z. Okay, so we know this now. Okay, so we're going to do part A. Okay, we're going to do part A. So now this is a 3D problem, right? We're going to solve this in the 2D world. Okay, and I'll show you how to solve this. If you visualize this in 3D, yeah, I get confused also, not just you. Okay, so I've devised a method to do this in a 2D world. Okay, which you will not make so much mistake. Okay, so now I'm going to view this structure. I'm going to view this structure. So this is X, Y, and then this is rotation in the Z. So I'm going to draw this structure now. Okay, so I'm going to draw this structure now. So one end is built in, right? And then over here, this is how our structure is drawn, right? You can see this, yes or no, right? And then by looking at the moments, okay, we know that moment about Z is in this direction, right? So like what I taught you guys before, once you know that is the moment, right? You know the head of the arrow is under what? Compression, right? The tail end is under what? Tensile. Okay. So if we were to draw the deformation pattern, the deformation pattern will look like this. Okay. The deformation pattern will look like this. And then I'm going to call this at the wall end. Okay. This is point A. And this is point B. Right? That's point B. Can anyone tell me if this structure were to fail, is it going to fail at point A or is it going to fail at point B? Anyone, please?
Point A.
Yeah. So if this thing is going to break, it's going to break at point A. Okay. Can anyone tell me why? You're absolutely right. But can anyone tell me why?
Because it's point of junction,
Hmm?
point of joint.
So yeah, you're partly right. So why?
Sorry, is it because like the layers can't shift there?
No, this is because at point A, bending moment will be maximum. Sorry, you are partly right also, okay? And it's also no movement, okay? No movement is allowed, okay? Right, you restrict motion, right? When you restrict motion, there'll be reaction, okay? So what do I mean by restrict motion? If I have a strong heart, okay, I jump. So this is our building in McMaster, okay? If this is the building, okay, I'm here, right? This is ETB. Some of you have not been to campus before, right? So when I jump, some of you will wish that I jump after you get your term test grade. But anyway, if I jump, so if this is 5, 4, 3, 2, 1 floor, when will I die? Anyone? Will I die when I hit the 5th floor? Yes or no? The answer is no. So when I come down, I won't die yet. Yes or no? When I down here, I still won't die yet. Okay, I'm still what? Why wouldn't I die if I have a strong heart? Anyone?
Because you can still move.
Yeah, there's still motion, right? So when I am not allowed to move anymore, right? Right? When I'm not allowed to move anymore, what happened? Why did I die? I hit the floor, and then what happened? Right? All the what? Yeah, impact. Okay, all the forces will hit upon my body, impact motion, impact energy, then I die. Okay, you control under the load, right? So likewise, at point B, it can move, yes or no? At point B, it can move.